Questions on any of this? Getting the null, the alternative, labeling which is the claim. Any of that stuff we talked about yesterday. No? Okay. So today, then, we are just going to add a few more pieces to our hypothesis testing puzzle here. Let me erase what's up here. Okay. So we're going to jump to kind of the end of hypothesis testing. So at the beginning, you're going to write claim your alternative, or your null, your alternative, and which is the claim. In the middle, we're going to do some math, so we'll get to that later. And at the end, you're going to make a decision about the hypothesis that is being tested. And so we're going to talk about the decision part today and a little bit tomorrow. All right, so it says, no matter which hypothesis represents your claim, you are always going to begin by assuming that the null hypothesis is true. So that will always be the assumption that is being made. And then we're going to do some math to figure out if we will accept that it's true or we will reject that it's true. So we don't usually use the word accept because there's always a little bit of a room for error when we're talking about statistics. So we either reject, we have enough information to show that something's false, or we do not reject is the other way you're going to see this worded. And sometimes they'll say fail to reject is another phrase you might see that means the same thing, okay? So when we make a decision at the end, we either reject the null hypothesis or we fail to reject or do not reject the null hypothesis. Because the decision that we're being made is based on a sample of our population, not on the population as a whole, there's always a room for error. So the first thing we're going to talk about today are the types of errors that can occur. So there's a type 1 error and there's a type 2 error. We'll see some examples of how these would happen in real life. So a type 1 error occurs when the null hypothesis is rejected, but it's actually true. So if something is true in real life, but we run statistics and determine that we're going to reject it. So our statistics show that it's false. Type 2 error will occur if the null hypothesis is not rejected when it's actually false. So if the null hypothesis is false in real life, but we don't have enough information from our statistics to show that it is false. The chart at the bottom here, you can apply to many different situations. This is pretty generic, doesn't really have a specific situation it's talking about. So again, we're always assuming that the null hypothesis is true. So on the top of my little grid here, we've got the truth. It's either really true or it's really false in real life. What are those two things? And then at the end of our hypothesis testing, we either do not reject it or we reject it. If we have a true hypothesis and we do not reject it, so we're not saying it's false, that is the correct decision that's made. If we have a false null hypothesis and we reject it, that is also the correct decision that is being made. When the errors occur is when it's true, but we reject it, so we say it's false, or vice versa. First thing I'm going to show you, I'm going to flip ahead 2 slides on yours, is a little YouTube video that I think gives you a great explanation. In this video, they're going to talk about alpha and beta. We do a little bit with alpha, but beta is something you do in a higher level statistics class, so you don't really need to worry about that. They just kind of briefly mention it. Let me see if I can get this to work.
In this lesson, we will learn about the errors that can be made in hypothesis testing. In general, we can have 2 types of errors, type 1 error and type 2 error. Sounds a bit boring, but this will be a fun lecture, I promise. First, we will define the problems, and then we will see some interesting examples. Type 1 error is when you reject a true null hypothesis, and it's the more serious error. It is also called a false positive. The probability of making this error is alpha, the level of significance. Since you, the researcher, choose the alpha, the responsibility for making this error lies solely on you. Type 2 error is when you accept a false null hypothesis. The probability of making this error is denoted by beta. Beta depends mainly on sample size and population variance. So if your topic is difficult to test due to hard sampling or has high variability, it is more likely to make this type of error. As you can imagine, if the data set is hard to test, it is not your fault. So type 2 error is considered a smaller problem. We should also mention that the probability of rejecting a false null hypothesis is equal to 1 minus beta. This is the researcher's goal, to reject a false null hypothesis. Therefore, 1 minus beta is called the power of the test. Generally, researchers increase the power of the test by increasing the sample size. This is a common table statisticians use to summarize the types of errors. Now, let's see an example that I heard from my professor back when I was studying statistics in university. You are in love with this girl from the other class, but are unsure if she likes you. There are two errors you can make. First, if she likes you back and you don't invite her out, you are making the type 1 error. The null hypothesis in this situation is, she likes you back. It turns out that she really did like you back. Unfortunately, you did not invite her out because after testing the situation, you wrongly thought the null hypothesis was false. In other words, you rejected a true null hypothesis and lost your chance. It is a very serious problem because you could have been made for each other, but you didn't even try. Now, imagine another situation. She doesn't like you back, but you go and invite her out. The null hypothesis is still, she likes you back, but this time it is false. In reality, she doesn't really like you back, that is. However, after testing, you accept the null hypothesis and wrongly go and invite her out. She tells you that she has a boyfriend that is much older, smarter, and better at statistics than you and turns her back. You made a type 2 error, accepted a false null hypothesis. However, it is no big deal as you go back to your normal life without her and soon forget about this awkward situation. Hypothesis testing is usually like that. You don't really want to make any of the two errors, but it happens sometimes. You should be aware that statistics is very useful, but not perfect. Alright, that's all from our love/life/statistics lesson. Thanks for watching.
I thought that was
For
cute.
more videos like this one,
Maybe appropriate as prom season approaches. Right? All right. So let's look at a couple examples. Just go back a slide on yours of when we could see type 1 and type 2 errors beyond asking somebody out in real life. So one common example that you'll see with this is when we are in a judicial system, we assume at the beginning that somebody is innocent until proven guilty, right? So the null hypothesis there is that the person is innocent. So the truth about our null hypothesis, and I'll label that at the top here. So when we say that they are innocent, we're saying that the null is true. And if we're saying they're guilty, we're saying that the null is false. Okay, so then there's two decisions that can be made from the jury. Either they can determine that somebody is not guilty or guilty. If they determine that the defendant is not guilty, that is them not rejecting the null hypothesis, okay? And if they determine that somebody is guilty, they are rejecting the null hypothesis, okay? So let's say you're on trial and you're innocent and the jury finds that you are innocent. Justice has been served, right? Or if you're on trial and you're guilty and the jury finds you guilty, again, justice has been served. If you're innocent, but you are found to be guilty, that's the type 1 error. And remember, that's the one in the video that they mentioned, is the more severe of the two, okay? If you're innocent and found guilty, that's pretty terrible. And then the other error that we might see is if you're guilty, but the jury finds you not guilty, okay? They don't have enough evidence to convict of a crime. Okay, so we might see those in real life. Another example are test results. This example, they're giving COVID-19 test results, but you could use this for any type of test, this type of table. So the null here is that we are assuming that you get a COVID test, and the assumption is that you will be COVID-19 negative, that your test result will be negative. Okay, so my null hypothesis, we are assuming it is either true or false. So if it is true, that means in real life I am COVID-19 negative. If it's false, that means in real life I am COVID-19 positive. And then there's two things that can happen, two decisions that can be made after the test. The test can find that you are either negative or positive. Okay, so a negative test result would be not rejecting, and a positive test result would be, if we're assuming that you're negative and it finds you're positive, we are rejecting that null. Okay, so if you're negative and the test result says you're negative, it's a good test, right? And if you're positive and the test result says you're positive, also a good test. If your COVID-19 status is negative, but the test result shows you are positive, that is a type 1 error. And in medical terms, they call it, they mentioned this in the video, a false positive. Okay, that's pretty bad if you're making a medical test, right? That this medical test is showing that you have some sort of positive result for something that you don't actually have. That's pretty terrible. And then the other one is a type 2 error. And that would be a false negative. Now, depending on what it's testing, that could also be pretty bad, right? Like if I'm COVID-19 positive and I have a test result that says I'm negative and I'm walking around making a bunch of people sick, that's maybe pretty bad. Okay, so it just depends what the test is showing. So that can not necessarily be great either, but we're going to see more common type 1 errors, and those are the more severe type 1 errors. Okay? Questions on any of that? Difference between the two? Okay. All right, so I'm going to jump ahead a little bit here. Go to this slide where it says level of significance. So we want to try to make the probability of creating either of these types of errors as low as possible when we do our hypothesis testing. And we use a level of significance to determine what our probability of getting a type 1 error is, okay? And that, remember, that's the more severe one. Common used level of significance is they're going to use alpha to represent that. You're either going to see, we want small numbers, small probabilities of making an error. So 10%, 5%, and 1%. 1% is obviously better. You're going to have less of a probability of making an error, but you're going to have more of a chance of rejecting something that's true. Sometimes you'll have more of a probability of making something that's a type 2 error. So we kind of balance it out here a little bit. Most of the problems that you guys are going to do, they will give you the level of significance to start. They're going to say use a level of significance of 0.05 to do this hypothesis test with this null and this alternative, okay? If not, though, if you have to pick, you're probably going to choose one of these. And these are going to be common values that we're going to see on our Z and our T charts again. Those are going to come back in when we start doing our calculations, okay? We already talked about this, so I'm just going to flip through it, what the test statistic is for each population value. Okay, so last thing we need to talk about today are p-values. So if the null hypothesis is true, then a p-value, or probability of the hypothesis test, is the probability of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. The p-value is essentially going to be an area that we're going to see on our normal curve. You can see that in the pictures down below. It's the probability of being in a specific region where we're able to either reject or not reject the null. And we'll determine a little bit later on whether we're in that region or not, if we're going to reject or not reject, and what that means. These three cases at the top, we saw yesterday, the three possibilities of what your null hypothesis could be. Either your null is greater than or equal to, less than or equal to, and on the next slide, equal to. And then the alternative is the complement of that. Going along with that now, we're going to determine, based on how my hypothesis looks, what kind of test are we going to create? And your options are going to either be left tail, right tail, or two-tailed test. And then we'll talk about later how to find the actual p-value that goes along with these. How you determine if you have a left tail, right tail, or two-tailed test is you are going to look at the alternative hypothesis there, okay? If it is less than, you will be using a p-value that is an area to the left. We talked a lot about that. That's the stuff that's on our Z-score chart, right? And that is a left tail test. You can see the left tail of our standard normal curve there is shaded. If our alternative hypothesis is greater, then we use a right tail test. and our p-value is an area to the right. We've talked about before how to calculate that, right? We find an area on our z-score chart, and then we do 1 minus. We do the complement of that. And then finally, on the next slide, you can see that third case where my null is equal to and my alternative is not equal to. This will create a two-tail test. And in this case, our p-value is divided in half. If you guys remember, we did a picture that kind of looked like this with confidence intervals. You're going to see when we get our critical values that we use for our hypothesis testing, it's going to be really similar to what we did with those confidence intervals as well. Okay, so last slide for the day. What you need for your homework. We've got two questions. We're going to write the null, the alternative, what the claim is, and then we're going to determine if this type of test would be a left tail, a right tail, or a two-tail test. Okay? So the first one says, the school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so what is the claim? Is the claim the null or the alternative here? Okay, yep, and it's proportion, so we're going to use P for our population parameter. The claim is that the people that are involved in at least one extracurricular activity equals 61%. Usually we see that written as a decimal. So what's the complement of that? P not equal to. Okay. As soon as I have that alternative hypothesis, that's enough to be able to tell you what kind of test you're going to complete. So will it be left tail, right tail, or two tail?
Two-tail.
It would be a two-tail test. And P will be split in half on either end of your standard normal curve. Okay, and we'll talk about how to calculate P and whatnot later. All right, number 2, car dealership announces that the mean time for an oil change is less than 15 minutes. So, is the null or alternative my claim? The alternative here is the claim. And the claim is being made about the mean, so make sure you use the appropriate variable there. The mean is less than 15 minutes, which means my null hypothesis is that the mean is greater than or equal to 15 minutes. Is this a left tail, right tail, or two-tail test?
Left or right tail? Or left?
Which one?
The left tail.
It's a left tail test. And the p-value will be associated with the area shaded to the left of whatever critical value that we find. Okay, yes?
The test goes with the claim.
The test goes with the alternative hypothesis.
Oh, always alternative.
Yes. So if it's less than, it's to the left. If it's greater than, it's to the right. If it's not equal to, it's both sides. All right, and that's where we're going to stop today. So you guys can now complete 7-1 Day 2 Math Excel. Remember, they're pretty quick. And then tomorrow we've got like 6 more slides just to wrap up 7-1. And then finally, Friday, we'll put all these pieces together and actually do a hypothesis test. Okay? All right, last 15 minutes are yours to work. I'll do cell phone lotto. That's all I got.